I am the chemistry coordinator and the chemistry teacher for grades 10, 11, and 12 in the German International School, Beirut. I have been teaching chemistry for 26 years. In this lesson, I will teach you how you can calculate the average atomic mass alone without having a teacher explaining to you the formula. You will discover the formula through a guided worksheet. So our objective is to calculate the average atomic mass. You need to round the answer to 2 digits after the decimal point when you calculate your answer. Iodine exists in nature in 3 isotopic forms. 80% of iodine in nature is I-127. 127 is the mass number of iodine having a relative abundance in nature equal to 80%. 17% of iodine present in nature is I-126, and 3% of iodine is I-128. Based on this given, what you should do in order to calculate the average atomic mass of iodine? Which formula should be applied? Is it needed to memorize the formula without understanding it? Of course, no. I will show you how to get the formula, how to construct the formula based on a guided worksheet that you have to follow. And you will be able to discover the formula without explaining it to you. So to be able to calculate the average atomic mass, you have to follow the following steps. Just fill in the blanks as it is shown in the samples. Of course, this is the periodic table, and our aim is to determine the atomic mass, the average atomic mass of iodine found in the periodic table. When we say 80% of iodine, I-127 means out of 100 atoms of iodine found in nature, there are 80 atoms, each having a mass number of 127 and hence an atomic mass of 127 AMU. If we understand the meaning of 80% of iodine, I-127, if we understand what it means, then we are able to do the same for 17% of iodine, I-126. What does it mean? Out of 100 atoms of iodine found in nature, there are 17 atoms, each having a mass number of 126 and hence an atomic mass of 126 AMU. So the student has to fill in the blanks based on what is given up as a sample. So the teacher will give one sample example, and the student will follow the same example in order to show understanding of the other percentages. What do we mean by 17% and what do we mean by 3%? So 3% of iodine, I-127 at 128 means that out of 100 atoms of iodine found in nature, there are 3 atoms, each having a mass number of 128 and hence an atomic mass of 128 AMU. So first, I need to understand the meaning of the percentages. What do we mean by 80%, 17%, and 3%? These are the percentage of abundance of iodine in nature. After understanding the meaning of these percentages, we are ready to go to the next step in the next page. So this is a table. This is a table that will allow me to work with these percentages and work with these atomic masses. So I-127 means the mass of one atom is 127 AMU. And the number of atoms, as we saw in the previous slide, it's 80. So if I want to calculate the mass of 80 atoms being given the mass of one atom, a simple math operation will give me the mass of the 80 atoms. So 80 times 127 will give me the mass of all the 80 atoms having a mass number of 127. So it will be 10,160 AMU. The student must follow this example in order to do the same for the other isotopes. So I-126 means the mass of one atom is 126 AMU. The number of atoms is equal to 17, as we saw in the previous page, and the mass of these 17 atoms must be equal to 2,142 AMU. The third isotope is I-128. The mass of one isotope is equal to 128 AMU. In nature, there are 3 out of 100 iodine atoms. 3 atoms have a mass number of 128. The total mass of these 3 atoms will be, with a simple math operation, 3 times 128 equal to 384 AMU. So as you saw, the teacher will give one example and the students will follow this example in order to calculate the masses of a certain number of isotopes out of 100 atoms present in nature to calculate the total mass for a given isotope. Now, number of atoms 80, 17, and 3, so the total number is 100 atoms, and I want the total mass of these 100 atoms belonging to different isotopes. So I have to add the masses that I calculated above. So 10,160 plus 2,142 plus 384, I will have 12,686 AMU. This is the mass of the 100 iodine atoms having different mass numbers, different isotopes. So this mass is for 100 atoms. What we need to know is the mass of one iodine atom, which is the average atomic mass. So when I say what is the mass of one iodine atom without specifying which isotope, I mean the element iodine, regardless, without mentioning which isotope. So which will be the average atomic mass of iodine as an element. So I have to divide the total mass of the 100 atoms by 100 because I want to know the mass of one atom. So by dividing by 100 atoms, I will be calculating the mass of one atom, and this is the average atomic mass of iodine, 126.86 AMU. So as you can see, this is a table, an organized table that will show the students how to calculate the average atomic mass and understand how the steps are done. Okay, so by doing the same, by following a certain example given by the teacher, the student will understand the mathematical operations that will be done because everything is displayed in a clear way, and the atoms will be calculated and their masses, and the average atomic mass will be calculated at the end, and the method will be easily understood by the students. After going through this guided example, now we will sum up by saying what should be the method that should be used. So calculating the average atomic mass, I can calculate the average atomic mass of an element from its isotope data by taking each atomic mass, multiplying it by its percentage, adding all the results together, and divide the sum by 100, which is the sum of all percentages. So I will be able to come up with the formula by following a specific example and following the steps in an easy way. I will be able to let the student construct this formula and come up with the conclusion by themselves. After completing this conclusion, after finding writing the rule, the students will be asked to apply to check understanding of the above method. And they are required to calculate the average atomic mass of iridium using the following data for 2 iridium isotopes. Iridium exists in nature in 2 isotopic forms. Iridium 191, so iridium 191 and iridium 193. Iridium 191 has an atomic mass of 191.0 AMU, and iridium 193 has an atomic mass of 193.0 AMU. The percentage of abundance of the first isotope is 37.58%, and the percentage of abundance of the second isotope is 62.42%. First, I need to make sure that the sum of the percentages is equal to 100. This will confirm that only these 2 isotopes are present in nature. Okay? If the percentage is not equal to 100, this means that I have a missing isotope that I need to search for. So since the percentage in our case is 100%, now I'm able to calculate the average atomic mass of iridium by following the rule that I obtained from the guided example. So the average atomic mass of iodine is calculated by first multiplying the percentage of each isotope by its atomic mass, add the products, and divide by 100. This is what we obtained as a mathematical operation based on the previous example. So if I multiply the percentage by the atomic mass, I will get the total masses for a given isotope. And if I add them and divide by 100, what do I get? I will get the average atomic mass of the element iridium, which is 192.2 AMU. So this is how to teach the students in an effective way, in a student-centered learning method, how to calculate the average atomic mass of a certain element. And further example, I will ask a student to calculate the average atomic mass of bromine. Bromine has 2 isotopes, bromine 79 and bromine 81. Given their atomic mass is 78.9183 AMU for Br79 and 80.9163 AMU for Br81, and the percentage of abundances are given, I need to make sure that their sum is equal to 100. After making sure that the sum is equal to 100, I will be able to start applying the formula that the students were able to construct based on the guided steps, and they will be able to determine the average atomic mass of a bromine by applying the formula, and this is what they will get if they follow what they learned by themselves. The average atomic mass of bromine is 79.90 AMU. I hope that the method is straightforward and it's easy, and the student will enjoy discovering the relation and the formula by themselves without being given the formula. The teacher should be a learning facilitator and not a spoon feeder. Thank you for listening and following my lesson. Hopefully, all my lessons will have the same structure. The students will be the discoverers. The students will discover what they will learn based on what they already know from their background and based on the assistance that the teacher will put in our hands in order to guide them to reach the outcome and complete the objectives of their lessons. Thank you for attending my lesson. Bye bye.